5.2 molar mass. The molar mass is the mass of 1 mole of an element. It is the atomic mass expressed in grams. So it is the AMU, it's the mass that's the larger number on the periodic table of a particular element, the atomic mass. That is going to be your molar mass. It is going to be the atomic mass expressed in grams. So the molar mass of 1 mole of silver is going to be 107.9 grams. The molar mass of 1 mole of carbon atoms has a mass of 12.01 grams. The molar mass of a mole of sulfur atoms has 32.07 grams. So what I just mentioned there, when we're trying to figure out what's the molar mass of a particular item, we are going to use that periodic table again. And it is the larger number on our periodic table. It is the atomic mass units. It is going to be expressed in grams. So give the molar mass for each element. Press pause, look on the periodic table, see if you can figure out what's the number to use to solve for these. Well, so you're back, and you've now looked on the periodic table, and you've looked up and saw the values for the particular atoms. So our guide to calculating the molar mass is we need to obtain the molar mass of each element, multiply each molar mass by the number of moles or subscript in the formula, and calculate the molar mass by adding the masses of the elements together. So in other words, we're not just looking up for one element, but we now need to find the molar mass of a particular compound. So we're going to find the molar mass of carbon, times it by 2, find the molar mass of hydrogen, times it by 6, find the molar mass of oxygen, there's only one of them, and then to figure out the overall molar mass of the whole compound, we are going to add those together. So, obtain the molar mass of each element. 1 mole of carbon is 12.0, mole of hydrogen is 1.01 grams, mole of oxygen is 16.0 grams. Then, we are going to say, okay, there's 2 carbons, so we have 2. Now then, our conversion, we need to have our moles cancel out. So 2 times 12 is going to be 24 grams. Okay, we have 6 here, so 6 moles of hydrogen. Well, for every 1 mole of hydrogen, it's 1.01 grams of hydrogen, so we're going to do that. Ditto for the oxygen. So then we have these 3 together, then we're going to add them up. So the molar mass of C2H6O is 46.1 grams of C2H6O. You'll notice here in this slide talks about the 1 mole quantities, and you might say, wow, why do they have different volumes? Well, that's because we're going to have different masses, because the elements in the periodic table have different masses. And we know that a mole is an amount, 6.02 times 10 to the 23rd, not the mass. So hence, it's going to be, and we know iron's nice and heavy, so we don't need a whole lot of that. And so you will notice here that, again, make sure you realize that a mole is 6.02 times 10 to the 23rd atoms or particular particles, not how much it weighs. So, what's the molar mass of each compound? Do it like what we just did with the last 2 slides ago, and come on back. So, we had K2O. First thing is we have to use the periodic table, look at the molar mass. K is 39.1 grams per mole, oxygen 16.2 grams per mole, aluminum is 27, oxygen 16, hydrogen is 1. So then step 2, we're going to have to take our number, that is the subscript, and multiply it by our molar mass. So for every 2 of our potassium, we're going to multiply it by the 39.1 grams of potassium for every 1 mole of potassium. So we get 78.2 grams of potassium. Then for every 1 mole of oxygen, there's only 1 oxygen here, We know that the conversion, we need to have the 1 mole on the bottom so that it cancels out the 1 mole here, and it is 16.0. Where did you get the 16.0? From the periodic table. So then we have these two, and then of course we'll add them together in a moment, but let's still see what we're going to do for the aluminum. So here we have for, there's understood to be 1 aluminum here. The molar mass of aluminum, when you looked it up, was 27.0 grams of aluminum. Oxygen, when you looked up the molar mass, is 16.0 grams of oxygen, but notice this 3 here means 3 times everything in these parentheses here. So 3 times our oxygen. So we have 48 grams of oxygen. Hydrogen, for the 3 moles of hydrogen, okay, the molar mass of for hydrogen is 1.01 grams, so the 1 mole hydrogen is on the bottom to cancel out the moles hydrogen here. 3 times 1.01 is 3.03. All right, now we add them together. So first of all, we're going to find the molar mass of K2O. So when we added up those individual things that we did, we get 94.2 grams of K2O. When we add up the individual moles of the aluminum and oxygen and hydrogen, we are going to get 78.0 grams of aluminum hydroxide. All right, here's another one. Go ahead and see if you can find the molar mass of Prozac. Notice its formula: C17H18F3NO. Well, the first thing is figure out the molar mass by looking on the periodic table of each of the following. So you do that, you get that. Now, we're going to have to see that there were 17 by the carb as a subscript next to the carbon, so 17 times 12. There was an 18 as a subscript to hydrogen. There was a 3 as a subscript to the fluorine. There was nothing as the subscript to nitrogen, and ditto for the oxygen. So when we multiplied these against their with their molar masses, we get these. Then of course the next step is to add it all together. So when you do, you get 309 grams of our Prozac. All right. Well, now then, we're going to be doing calculations using what you've just done. And you may think, oh, I've just done calculations. Well, you just did this first step in using these for calculations. So knowing how to do the molar mass, we can now figure out and relate grams and moles of an element or compound. So here we go. So for example, we can have our ratio that, if we looked up the molar mass of our methane, so carbon is going to be our 12, hydrogen's 1 times 4, so that's 4, so 12 plus 4 is 16. So we can say that 16.0 grams of methane is 1 mole of methane, or we could have switched it and said 1 mole of methane is 16.0 grams of methane. So here's our guide to calculating the moles or grams of a substance from grams or moles. State the given and needed quantities. Write a plan to convert moles to grams or grams to moles. Determine the molar mass and write conversion factors. Set up the problem to convert moles to grams or grams to moles. A box of table salt NaCl contains 737 grams of NaCl. How many moles of NaCl are in the box? So the first thing we're going to say is, okay, we're going to start with 737 grams of sodium chloride. We need to get to moles, and we know we do that via the molar mass. So you need to look up the molar mass for our sodium chloride. Sodium's value on the periodic table is 23.0 grams, and so we have for our NaCl, there's 1 mole, so our 1 mole is going to cancel out top and bottom, so 1 times 23 is 23 grams of Na. Our chlorine is 35.5, so 1 times 35.5 is 35.5. We add them together to get 58.5 grams of NaCl. So we know we can either use the conversion, 58.5 grams of NaCl is 1 mole of NaCl, or we can say, okay, 1 mole of NaCl is 58.5 grams of NaCl. Whatever is going to be needed. All right? Well, they gave us grams and asked for moles. That means we have to cancel out the grams. In order to cancel out the grams, the conversion we need is to have the 1 mole of NaCl over the 58.5 grams of NaCl. So we have 737 grams of NaCl times 1 mole of NaCl over 58.5 grams of NaCl. The grams of NaCl cancels out. Our label is moles of NaCl. When we do the math, 737 divided by 58.5, you get 12.6 moles of NaCl. So here's our little nice road map here. Notice we are going to get from mass to moles or from moles to mass via the molar mass, which we are going to calculate using the periodic table. Only if we need to get to atoms or particles are we going to be using Avogadro's number. And if we do use Avogadro's number, we must go through moles. There is no direct roadmap to get from grams to atoms or atoms to grams. We all have to go through moles. So, our allyl sulfide, C6H10S, is a compound that has the odor of garlic. How many moles of our allyl sulfide are in 225 grams? All right, so all we have to do is to go from grams to moles. We're going to do that via the periodic table. See if you can do that. So the first thing we're going to do is we say, okay, we are given this many grams, we need to get to moles. We think, okay, we're going to use the molar mass, meaning looking at the periodic table for the molar mass, and calculate the molar mass in order to get to the number of moles. So again, we have 12 grams of carbon is 1 mole of carbon. And you look up at carbon's molar mass. We have 6 of them, so 6 times 12 is this. There are 10 moles of hydrogen. We look up the molar mass of hydrogen. By now you probably know it, 1.01 grams of hydrogen over 1 mole. For the sulfur, we have 1 mole of sulfur. We look up the molar mass of sulfur. It's 32.1 grams of sulfur. So we have these 3 items. We're going to add them together. So for 1 mole of our allyl sulfide, we have 114.2 grams of it. So then the next question is, which way are we going to need to write it? Are we going to have the 114.2 on top or the 114.2 on the bottom? Well, in order to answer that, you first start your problem finally and say, okay, I'm given 225 grams of C6H10S. So that is given first. So we know that the grams of the C6H10S have to be on the bottom to cancel out what they gave us. So that means the 1 mole of our allyl sulfide over 114.2 grams. So we're going to have 225 grams times 1 divided by 114.2. And when you do that math, you get 1.97 moles of our C6H10S.